Saturn has 62 confirmed orbital satellites, many less than 50 kilometers in diameter. The bulk of the larger spherical moons are predominantly water ice and a small amount of rock. They include Mimas, Enceladus, Thetis, Dione, and Rhea. Enceladus is covered in ice with a subsurface ocean at the southern pole. Geologically active in the southern region, geysers have been observed. This would be from tidal heating and orbital resonance with Dione and Rhea, and could contain a liquid ocean heated by internal radioactive decay. However, the prize of the Saturnian system is undoubtedly Titan. Titan is the only moon with a dense atmosphere, and, other than Earth, the only body to have stable bodies of surface liquid. It is larger than both the planet Mercury and our own moon. Cassini deposited the probe Huygens on its surface in 2005.
Titan is Saturn's largest moon. It's actually the second largest moon in the solar system, and it's the only moon in the solar system that has a large and substantial atmosphere. And that atmosphere in some respects is really similar to that of the Earth, being composed mainly of nitrogen, but in other respects it's really different. It has methane as its second most abundant gas, and that takes the same role as water vapor in the Earth's atmosphere. It evaporates from the surface, it forms clouds, and then rains down again, and in fact forms lakes that we see at Titan's North Pole, including ethane and propane and all sorts of complex chemicals. We also see these vast dune fields at the equator, which are not made of silicates as they are on the Earth, but actually made of organic substances, essentially plastics, which have actually sedimented from the atmosphere and are being blown around into dune fields, the same as we'd see on a desert on the Earth. And through this we can detect which molecules are in the atmosphere. We see all the molecules that were previously discovered by Voyager. But we're also able to look for new molecules, and in fact, buried within the signatures of these more abundant molecular species, we saw a very small spike, which was due to a new species which had not been seen before. And in fact, this was propylene. So the discovery of propylene on Titan is really exciting. First of all, it completes this chemical family where we had this missing link dating 32 years back to Voyager. But also it shows that there's much more there still in Titan's atmosphere to be discovered. Some people think that Titan is similar to the prebiotic Earth long ago, when the molecules were forming the basis of life. And we don't know what we're going to find on Titan if we send back further spacecraft with new instruments, more sensitive instruments, if some of the molecules on Titan could be similar to the basis of life on Earth.
NASA is preparing a new probe to follow in Cassini's footsteps. It is called the Titan-Saturn System Mission.
Cassini was able to look at the lakes, get a sense of the coarse composition of the lakes, but nothing about the organic molecules that are dissolved in the lakes. The Titan-Saturn System Mission is a 3-in-1 mission with an orbiter for Titan, a balloon that will float through Titan's atmosphere, and a lander that will splash down on one of the northern lakes of Titan. This mission will actually go into a lake, sample the liquid directly, see what the organic molecules are that are present. The Titan-Saturn System Mission also will go to Enceladus, a tinier moon, 1,000 times smaller than Titan, which has volcanoes, geysers essentially, that are spewing material from the inside of this moon outward. And it's a chance to see whether there might be molecules that would indicate that life has actually formed within the source region of these geysers. These geysers have water ice, and we strongly suspect that there's liquid water in the region that these geysers are coming from. We know there are organic molecules there because they've been measured by Cassini. The ability to follow this up quickly is essential because with Cassini-Huygens, we have now trained a generation of scientists who are ready to take a new generation of instruments and capabilities back to Titan and Enceladus and really answer the questions that Cassini-Huygens has left for us. And that continuity of knowledge and of enthusiasm is essential and very difficult to maintain in the outer solar system because trip times are so long. the Titan-Saturn system mission really is Jules Verne realized. It's a kind of planetary exploration that we have never ever done before anywhere else in the solar system and can only be done on Titan. This mission will touch the human heart in terms of the way it's exploring this fascinating world. It will be floating on the surface of a lake. It will be floating through the atmosphere. It will be revealing the entire surface from orbit at the same time. As we think of exploration, of unveiling a new world, it's exploration in the true sense of the word.
The planet Uranus has 27 known moons, grouped in 3 categories: 13 inner moons, 5 major moons, and 9 irregulars. Only Voyager 2 has passed by these worlds. There remains much to learn. The major moons in order from the planet are Miranda, Ariel, Umbriel, Titania, and Oberon. 4 of these moons have known internal processes such as volcanism and surface canyon formation. Miranda is the smallest of Uranus's round moons and one of the smallest objects in the solar system to be spherical under its own gravity. Strangely, it also has the tallest cliffs in the solar system. Thought to consist of equal parts of rock and ice, Ariel's surface terrain, probably of ice, is cross-cut with canyons, scarps and ridges. Umbriel is again thought to consist of rock and ice. Its surface is the darkest of the moons and heavily cratered. The surface seems to have gone through some form of surface heating that destroyed its very early features. Titania is the largest of Uranus's moons. Similar in composition, heavy cratering has been obscured by changes to the surface through some heating event like its sister Umbriel. Titania may have a tenuous atmosphere, as carbon dioxide and water ice have been detected on its surface. Oberon, the outermost of the spherical moons, seems similar to the others: ice and rock and heavily cratered. The surface has numerous scarps and graben from crustal movement. There are currently no plans to revisit these worlds. Neptune has 14 known moons, categorized into 2 groups, the regulars and the irregulars. The inner 7 moons orbit normally. The remaining half, including its largest moon Triton, orbit in either an eccentric, inclined, or retrograde motion. Triton orbits in the opposite direction to Neptune's spin. Scientists believe it was probably captured by Neptune's gravity in the early days of the solar system. Triton has an atmosphere that forms clouds and haze and is the only moon closely observed by Voyager on its flyby of the system. However, Neptune plays a very important role at the edge of the solar system. The planets formed from a disk of dust surrounding our Sun billions of years ago. Remnants of this disk still remain: the rocky asteroid belt influenced by Jupiter and the icy debris cloud beyond Neptune.
Neptune creates a ring structure in the dust cloud which features a gap where the planet itself resides. And this gap should make it fairly easy to tell where Neptune is from afar, even at distances where the planet is too dim to detect directly. The supercomputer simulations that Mark Kushner and I performed also allow us to see what the dust in the solar system may have looked like when the solar system was much younger. In effect, we can go back in time and see how the distant view of the solar system may have changed. When we included collisions between dust particles, we were really amazed by what we saw. Dust collisions change Neptune's gravitational imprint. The gap in the ring structure disappears.
Over billions of years, Neptune shepherds the dust cloud into an outer ring to what is now called the Kuiper Belt. The New Horizons spacecraft is exploring this region with its first flyby of the enigmatic Pluto and its moon Charon. Charon is the largest of Pluto's 5 moons. The other four orbit in erratic motion around the Pluto-Charon pair. Nix and Hydra are both odd-shaped, contributing to their erratic orbital motions. This is Hydra, taken by New Horizons from a distance of nearly 650,000 kilometers, revealing its irregular shape. Pluto was the first of these trans-Neptunian objects detected and first thought to be a ninth planet.
And then Pluto was this kind of, odd guy out. It was this little object at the edge of the solar system. And then when we found all these other Kuiper Belt objects, this is kind of almost a third type of object.
So for the first time ever, we'll be able to fly by a brand new object, an object that's been forming for billions of years, and understand what outer parts of the solar system are all about.
Pluto is the first of the Kuiper Belt objects, or KBOs, to be seen up close. There are many other KBOs, or dwarf planets, awaiting detailed scrutiny, such as Eris, almost the size of Mercury, and Quaoar, the first KBO discovered. The most eccentric orbit belongs to Senda, which has an elliptical orbit of 11,000 years, taking it to the icy Oort cloud at the edge of the solar system. The Oort cloud will one day become the new frontier.